So the question of May 2017, question 1 says, part A, Furahia Limited, an events management company, is considering whether to advertise an outdoor concert. The sale of tickets is dependent on weather, as indicated below. If the weather is poor, it is expected that 5,000 tickets will be sold without advertising. There is a 70% chance that the weather will be poor. If the weather is good, it is expected that 10,000 tickets will be sold without advertising. There is a 30% chance that the weather will be good. If the concert is advertised and the weather is poor, there is a 60% chance that advertising will stimulate further demand and ticket sales will increase to 7,000. If the concert is advertised and the weather is good, there is a 25% chance that advertising will stimulate further demand and ticket sales will increase to 13,000. The profit expected before deducting the cost of advertising at different levels of ticket sales are as follows. So we are given that the cost of advertising the concert is expected to be 15 million. Now, using a decision tree, advise the management of Furahia Limited on whether the outdoor concert should be advertised or not. Should be advertised or not. I wanted to get a hard copy of the paper instead of keeping on shifting the windows. Let me get the hard copy. The hard copy. So, when you look at that question, we said, Carol, good evening and welcome.
Thank you.
So we said that the first thing is always to come up with the objective. And the objective in this case is to maximize the profits. The next thing is to know what are the options that are available. And we said option is what is within the control of the decision maker. So these guys can decide whether to place an advert or no advert. That's purely within their control. Whether to place an advert or not. But there are, or rather after you have identified the options, then you identify the outcomes. Now, outcomes, I told you, they must be accompanied by probabilities and they are beyond control of the decision maker. In this question, there are two things that have been mentioned. That there is the issue of weather, the climate, and there is also the issue of the demand. Now, weather is something that is beyond control. So, we are told there are two states of weather. It can either be good or poor or poor and good. Yeah. Then, if you do the advert, we are told there is a possibility you can stimulate demand or not stimulate if you do the advert. Those are outcomes. So after that now, you get to know, is it a single stage decision or a multiple stage decision? Now this is a multiple stage because you can see we have more than one types of outcomes. Tuko na hizi za weather na tuko na hizi za demand. So those are two. There are more than one. And then I also told you the sets of probabilities. So ukiangalia kuna probabilities za weather na kuna probabilities za demand. So that qualifies it to be multiple. After that, now you compute the payoffs. So the payoffs have already been given. So if you have been given the payoffs, sasa ni kuipanga namna hii in a fair way, in a way that can be understood. So up to that point, kama kuna kitu umepotea, let me know. If we are good, then we now estimate the space that our diagram will take. The space, na nimesahau kuhesabu how many tails. Need to hesabu, tumesema you advertise or not advertise, the weather is good or not good. Yeah, kwa namna hiyo. It's always good to know how many tails. So these are 4, so those will be 6 tails. Those will be 6 tails. So if there are 6, so this is the payoff. So 1, 2, 3, 4, 5, 6. So tumesema hapa there are 2 possibilities. Hizi naweza zifanya kuwe mrefu. Yes, so once you finish drawing that way, let me know. Okay, so we are done. So if you are done, tumeambiwa you can choose to advertise. So you place an advert here. So unaandika advert. Na tumeambiwa the cost of the advert is 15 million. We can work with the figures being 15, being in millions. Remember, this is our decision tree. This is our decision tree. So hapa unaweka 15 na huwa inawekwa hivyo ikiwa kwa brackets. Hivyo. Then this side, no advert. No advert. No advert. Then we are told the weather, if the weather is poor, so the weather can be poor. So let's start here. The weather can be poor or can be good. The weather can be poor or can be good. That way. Now they are saying if the weather is poor, it is expected that 5,000 tickets will be sold without advertising. So without advertising and poor, you sell 5,000 tickets. 5,000 tickets. 5,000 tickets. There is 70% chance that the weather would be poor. So that means the probability is 0.7. And obviously now being good, it must be 0.3. It must be 0.3. It must be 0.3. The next statement inasema, if the weather is good, it is expected that 10,000 tickets will be sold without advertising. So you sell 10,000 here. Tickets. Without advertising. And there is a 30%, or I already have put it there. Then we are told, if the concert is advertised and the weather is poor, so you advertise and poor. If it is advertised, if the weather is, imepotea. Niko kwa bullet 3. If the weather is advertised and the weather is, or rather, if the concert is advertised and the weather is poor, there is 60% chance that the advertising will stimulate further demand and ticket sales will increase to 7,000. So there are two possibilities. You advertise and you stimulate further demand. So we'll say, I'm looking for a word that will be shorter to accommodate there. Increase. Can I, ama nitumie to stimulate. It will stimulate. It will stimulate, let me just use that, to 7,000 tickets. 7,000 tickets. And the probability of that happening is 0.6. 0.6. If the concert is advertised and the weather is good, so you advertise and the weather is good, there is a 25% chance that the advert will stimulate further demand. So here we stimulate. further demand to 13,000. About 10,000 tickets. And the probability of that happening is 0.25. 0.25. 0.25. So that is all that we are told. But you see, we don't have information for this one and this one. So if we are told it will stimulate, then the other chance that remains is that there is no stimulation. So if there is no stimulation, it is just normal. So let me just call it normal. So if it is normal, normal is just like when we did not have the advert and we were poor. We had 5,000 tickets. 5,000 tickets. So the probability of that happening is 0.6, 0.4. If you don't stimulate, that's what will happen. Then this one, the same thing, normal. And normal when we are good. Normal when we are good is 10,000 tickets. And this will be 0.75. 10,000 tickets, and that will be 0.75. The next thing is to insert the payoffs. The payoffs, we are told, we are given the number of tickets up, and you can see the profit. So what we shall be doing, utakuwa unaangalia the number of tickets, alafu unachukua profit yake. Like now, tukichukua ticket here 7,000, 7,000 inaleta 35. And remember, we are working with millions. So this is 35. The next one is 5,000. So 5,000 inaleta negative 20. The next one is 13,000. 13,000 inaleta 150. The next is 10,000. 10,000 inaleta 90. 5,000 tushajua inaleta negative 20. Na 10,000 tumejua inaleta 90. So that is what we have there. Once you have drawn the tree and you have recorded those associated values, the next thing I told you is to compute the EMV. Is you do computation of EMV. So say computation of EMV. Computation of expected monetary value at node. Node ni hizi tumenamba. Easy. So node 1. Node 1. I told you ukishafika hapo kwa number 1, unaangalia which lines are going out. If the lines which are going out are complete EV and they have probabilities, you take these probabilities multiplied by these values as you add. If the lines which are going out of that node are complete, Hizi ndio zinaitwa incomplete hizi. So if the lines are complete and they have probabilities, you take these probabilities, you multiply by the corresponding payoffs as you add. Higher. So that will be 0.6 times 35 plus 0.4 times minus 20. But now before you write the answer, you check which line is coming into that node. Which line is coming into that node. So if the line coming in is a complete one, you just write the answer. There is no problem. But if the line coming in is incomplete and it has a cost, you see like this one, coming in is incomplete and it has a cost, you subtract. Or in simple words, if the line coming in has a cost, you subtract that cost. But kama haina cost, you just write your answer. Like now in this case, proceed and give me the answer now. That team. Number 2, we do the same. The lines going out are complete. So it is 0.25 times 150 plus 0.75 times 90. Or 105. You go to number 3. The lines going out. Now, sasa hapa hatuna probabilities. Now, when you have not been given the probabilities, you estimate. And the best you can estimate is half-half. Because we are told the weather, no, we are not going to estimate. We are already given. We were given the probabilities of poor and good. Okay. But my point is, if we were not given and there are 2, you take half-half. But now here, we are already told poor is 0.7 and good is 0.3. Higher. So, kwa 3, it is 0.7 times what we have in the node where that line is going. Where that line is going to number 1. We have 13. Then plus 0.3 times where that line is going, number 2, 105. And I've told you before you write the answer, you check. Before you write the answer, you check who is coming in. So this one is coming in at 15. So you minus 15. And I think it's good to separate these ones so that hii isitolewe kwa hii kwanza. I'm waiting for the answer. Okay. Good. Carol, 25.6. The others, can you confirm? Good, it's confirmed. So let's go to number 4. So number 4, the same argument. It will be 0.7 times minus 20 plus 0.3 times 90. Now there, we do not have a cost coming in. That's the answer already, 13. Okay, good. Then we have number 5. Number 5, if the lines moving out, are incomplete, what you do, you select. That's what we said. So here you take the higher EMV at nodes where those lines are going. So they are going to 3 and 4. Nodes 3 and 4. So the higher of 3 and 4. 3 iko na 25, 4 iko na 13. So we'll take 25.6. And this one that we have taken, you come and mark that we have taken it here from the advert. Hapo, you mark that way. When you put those 2 lines, inaonyesha that you have selected that route. You have selected that route. So the question was, using decision tree, advice on whether the outdoor concert should be advertised. So the advice is that you should now advertise. That's what you have said. So the advice is advertise. That's the advice that we are going to give, that we advertise. There is something that you can also be taught to compute called value of information. Value of information. So when we computed the SIGOs, ile tulikuwa tunaita the payoff table, I gave you the formula of computing the value of information. The formula of computing the value of information. But when you are in the tree, when you are using the tree diagram, the value of information, you get it like this. You just come here at the end here. You follow the 2 lines that are coming out, or the 3, because there are others that will have 3. Whatever number they are. Whatever number they are, you pick the highest. So the highest, hapa kuna 3 na 4. So 3 ndio iko na the highest. Then you subtract the second highest. So now that here there are 2, 4 iko na 13. So that will give us 12.6. It's as simple as that. Unakuja hapa at the start. When you come there at the start, if there are 2, unachukua the higher, una subtract the lower. If they are 3 or whatever number they are, unachukua the highest, una subtract the second highest. Highest, you subtract the second highest.
Pardon? The value of information.
I'm saying you come here, hapa mwisho, or mwanzo. You can call it mwisho or mwanzo, depending on how you look at it. But here, unaangalia how many lines are coming out. Like now hii, there are 2. Kuna hii, inakuja hapa, na kuna hii. So you take the EMVs of the 2 positions. Ya 3, tulipata hii. Ya 4, tulipata hii. So the higher, you subtract the lower. So 25 minus this. Unapata hiyo. Is that okay?
Okay.
But assuming there were 3, because you can also get 3 of them. Assuming kulikuwa na ingine hapa, which is number 5. Nayo ilikuwa imepata 17. Assuming there were 3. So now the value of information sasa hapa itapatikana as, so now you are comparing, hii iko na 25, hii iko na 17 na hii iko na 13. Sasa utachukua hii, that's the highest, alafu subtract the second highest. Hiyo tumeelewa kabisa eh? Haya. Let's look at part B of that question. Part B of that question inasema, Samoa Limited has to decide which of the 3 newly on 3 new mutually exclusive products, X, Y, Z, to launch. The company's directors believe that the demand for the 3 products will vary depending on the competitors' reaction. There is a 30% chance that the competitors' reaction will be strong, a 20% chance that the competitors' reaction will be normal, and 50% chance that the competitors' reaction will be weak. The company uses expected value to make this type of decision. The net present values of the possible outcomes are as follows. So we are given that a market researcher believes that he could provide perfect information to potential competitors' reaction in the above market. Now advise the management of Samoa Limited on the maximum amount that should be paid for the information from the market researcher. Okay, so if that be the case, then that is, they already have given us the summary. So it's a case of single stage. 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 If you want to duplicate the table, you can still copy. Though no much value is added, but just to comply with our style. So the payoff table, so in the payoff table, on this side, I told you we bring the options. And here we have the outcome. So the options are what are within control. So this is product X. product X, product Y, product Z. Those ones are within control. Then probability. Probability. The outcomes are, it can be strong, it can be normal, it can be weak. And then you will have the EMV. So sasa, we can bring the values. For product X, ama tukifuata strong, we have 400, I have 800 kwa Y, and 1200 kwa Z. Then kifuata normal ni 600, 1200 and 800. Weak, I have 1000, 1600 and 1000. Alafu tulikuwa tumeambiwa hapo juu that the probability of being strong is 0.3. Being normal is 0.2. And being weak is 0.5. 0.5. So with that, we are told to get the value of information. So if you are told to get the value of information, value of information, value of information. I told you the formula we use when you are in the case of a SIGO. It is the EMV. The EMV with information minus the best EMV without information. That's how we go about it. So with information, the EMV I told you in our last lesson that what you do, you pick the highest. Like now hapa kwa strong, kukuja kwa hii outcome ya strong, the highest payoff is 1200. unaimultiply na 0.3 plus ukikuja kwa normal, the highest is also 1200 and the probability for it is 0.2 plus the highest here in a week is 1600. Yeah, so that is how you shall get the tell me what you have gotten. 1400. Someone else to confirm? Yeah, so it's confirmed. So if it's confirmed, we proceed and say without information. Without information. So without information, we have the option here, and then we have the EMV here. So let's start with X. We start with X. With X, unafuata sasa, hapa hakuna kuchagua, unaenda na hiyo yote. So it is 400 times 0.3 plus 600 times 0.2 plus 1000 times 0.5. Yeah, 740. 740. Higher. Then we go to Y. Y, we do the same thing of 800 times 0.3 plus 1200 times 0.2 plus 1600 times 0.5. Yes, 1280, good. Then Z. Z is 1200 times 0.3 plus 800 times 0.2 plus 1000 times 0.5. 10, 20. So these 10, 20, or these values, they are the ones you can bring here. 740, 1280, 1020. So the highest or the best of them, because you're taught to use the best is this. The best is that. So therefore, value of information. Value of information is the EMV with information. So with, we got 1400. Then the best without is 1280. The best without is 1280. So we have 120. So that is how we compute the value of information. If you have any question, you can raise it. If we are okay, say my yes.
Yes.
Okay. Benedette. Caro, also okay. Patricia also okay. Good. So, for your assignment, I'd like you to handle November 2017. November 2017, question 4A. November 2017, question 4A. November 2017, question 4A. And you can also handle December 2013. December 2013, question 4A. December 2013, question 4A. So I think that is good. I want us to take a break of like 5 minutes. Just 5 minutes. As I mark our registers, then we switch to the next topic. Because you're done with that topic, 1. So we will be so just a few minutes. Yeah, good. I'm done. Uh, Let me share the screen so that we discuss the next topic. I don't think I've sent you the notes for that. I will be sending after this if I have not sent. Don't think I've sent. Good. So the next topic is what we are calling the cost forecasting. Cost forecasting. This is the basis of management accounting. So it's a very, very important topic. Now, this cost forecasting is the process of predicting. Now, to predict means to tell in advance. The process of predicting the amount of costs. Now, the word cost refers to the monetary value of all the economic resources being used in the production of a product or provision of a service. Like now, what I'm doing, this is a service I'm providing. I'm using electricity, I'm using internet, I'm using my own labor. All those, when you combine them and express them in terms of money, that gives me the costs of doing what I'm doing now. We have various types of cost, very, very many costs or types. And one of the things that we mentioned in topic number 1 is that we must be able to control costs. We must be able to control costs. Oh, okay. Benedetta tells me that I sent the notes as well. Oh, great, great. So if I sent them, that's good. So I hope everyone has them. If you don't have them, or if you have not seen them, you can let us know. We will forward. Okay, so I was saying that one of the things that we need to do is to be able to control costs. But as you control something, it would be much easier if you are able to classify, if you are able to group them. Naweka kado, hawa kado, hawa kado. Is the concept of divide and rule. Now, in that case, we have very, very many ways of classifying costs. But the most common are, number 1, classification according to the activity level. Now, this is where we look at how does the total amount change as you change the activity level. Activity level is the measure of the purpose of the business. It's the measure of the purpose or the main reason why the business exists. Like now, Chacham, as a school or as a trainer, we exist to train. So how many students we have is our activity level. If you go to a hospital, the number of patients they have served, that is their activity level. If you go to a workshop, for example, woodwork, the number of items, maybe chairs or tables, that's the activity level. So if costs are changing as you change the activity level, that cost is called variable. If it is not changing, it is called fixed. And if it has the 2 components, it is called mixed. Mixed. Something else that will be coming in very, very handy is that whenever you are dealing with fixed, we always express them as a total figure. When you are dealing with variable, we first of all express them as per unit. Yeah, those 2 pieces of information, very, very important. The next one is classification according to product. Now here we are looking at, can the cost be identified with the product? can we say that we incurred this cost purely because of this product? For example, can I say that I am paying this electricity purely because of teaching you people? Such that if I am not teaching, there will be no power in this room. If yes, that cost is called direct. It can be clearly identified as in there is only rights in this room when I'm teaching. But if there are rights when I'm teaching and when I am not teaching, it then means that the cost of electricity is not directly identifiable in the class. So that will be taken as indirect. It will be taken as indirect. We also have some costs which can be clearly identified with the product, but they are so small. You see, like now the cost of this pen, andiki kalamu ni ya 150 shillings. Na naweza funza nayo 2 or 3 semesters. Ile rangi natumia hapa, it is around 500. It can go for a month. So if I was now to apportion that, first of all, hii kalamu na rangi, they are directly identifiable to this class because I can only write when I'm teaching. But sasa nikisema nitagawa hiyo cost, nigawie all the students that I'm teaching, ndio nijue per student natumia rangi ya pesa ngapi. It may not make economical sense. So even those ones, we classify them as indirect, or they are known as overheads. So those are the two main cost classifications that are very, very important as far as the topic of forecasting is concerned. But as I've said, we have very, very many other types of costs. Cost forecasting is based on the assumption that total cost can be objectively and accurately separated into fixed and variable cost. So this is an assumption we make, that when you are given the total costs, you can be able to tell which one is fixed and which one is variable. Yeah, we are making an assumption because different people may classify things differently. Yeah. Then this is expressed in form of a linear equation, y is equals to a plus bx, whereby y represents total costs, a represents the total fixed cost, b represents the unit variable cost, x represents the measure of activity level such as units or hours. Now this concept here, it is very, very important as far as this subject is concerned. You will keep on coming across it in other topics. So lazima uelewe haka vizuri. It's very simple, but you must understand it. That y represents total cost, a represents the total fixed cost, b represents the unit variable cost, and x represents the measure of activity. Now, the following steps are followed when you're developing a cost function, if you are a consultant, but kwa maswali hapa kwa CASNEB, you may not follow all the steps the way they are. So number one, you need to know what is the dependent variable. Dependent variable is the cost or is the value that you want to predict its amount. The independent variable, independent is the one that when it changes, it makes y to change. Then analyze and plot the data on a graph. After you have done, or you gather the data, then you analyze, then you observe the pattern portrayed, and then you test reliability. So for us, maybe we will do some questions up to that point, so that we now come and develop the equation. We will not plot the data. We will not gather the data. CASNEB will have given that. Then we will also do a bit of testing reliability, how good the equation is. Now we have various methods that are used in cost forecasting. One is called scatter diagram. Now a scatter diagram is a diagram, I'll discuss when I'm here. So we have all this, but for our syllabus, we shall not discuss this. These are for quantitative analysis. They are not in your syllabus. So time series analysis is not there. Input output is not there. Markov analysis is not there. So, but it's good to know that there are methods used in forecasting. So we will confine ourselves to the first 7. Now, starting with the scatter diagram. Scatter diagram, as the name suggests, it is simply where you plot the values. Unachukua hiyo data, unaziweka kwa graph. And when you put them in the graph, the graph will show you the direction of the costs, and you'll have an idea whether these costs are increasing or they are constant or they are reducing. So it gives you an idea that if this is what has happened when I have produced like 50 units, chances are when tomorrow I do 20 units, cost yangu zitakuwa hapa, ama when tomorrow I do 190 units, cost zangu zitakuwa hapa. So it gives you an idea. It gives you an idea. That's scatter diagram. This one you cannot get in the exam, not unless they ask you what is a scatter diagram. There's no computation. Number 2 is called industrial engineering. Now, industrial engineering, it is where a qualified engineer gives you the quantities of the inputs that are required to make the product that you want. They call it the BQ, the bill of quantities. Sasa ukishapewa hiyo BQ, ndio unaenda sokoni unatafuta the costs, and then from there you are able to know how much will it cost me to do this project. It is the same thing we do even in our kitchen. You people, you are ladies, you understand this very well. Ukiambiwa kwako kuna kuja wageni 10, and you want to cook for them rice and chapati and ugali, you'll be able, first of all, you sit down, unasema wageni 10 mchere kiasi hii, wageni 10 maziwa kiasi hii, unga kiasi hii, unga ya chapo kiasi hii. Then ukishajua the quantities, sasa unapiga bei. Unga ni hii pesa, nyama ni hii pesa. Then you are able to say that for me to host those 10 guys, this is how much it will cost me. That's an example of industrial engineering. Very, very simple. So you will also take time and look at these other details given. Not very, very important in the exam. Then we have what we call the accounts analysis method. This accounts analysis method, it involves classification of costs as fixed and variable. So here we look at the costs and say, are they fixed? Are they variable? Then we put them into 2 categories. Then using the totals we have, we develop an equation of y is equals to a plus bx. And that method is very simple, very economical, and easy to use. Now, I don't know whether the handout I've given you has this question. Does it have? Let me know whether the handout has that question.
No.
Or it doesn't? Okay. Aye. So then that means I never intended you to solve that. I want us to solve one in the past papers. So get your past papers. Let me tell you the question we shall solve. Get your past papers. And look for a question that was tested in 2004. December 2004, question 1. December 2004, question number 1. December 2004, question number 1. Iona niambie. So we are in chapter 2, cost forecasting. Resha ameiona. So we are using account analysis. We have said this December 2004. Question 1. Yes, Benedette. Carol, you found it. Question number 1A. Carol, umeiona?
Yes.
Good. So the question says, Maisha Meta Products Limited has prepared a schedule of estimated overhead costs for the coming year. The schedule was prepared on the assumption that production would amount to 800,000 units. Costs have been classified as either fixed or variable according to the judgment of the financial controller. The following overhead cost items and their classification as either fixed or variable form the basis for the overhead cost schedule. So we are given that schedule item and the total cost. Now, the other information that is given, we shall not read them because they are not relevant to what I want us to do, because we are just confining ourselves for now to part A. Okay, teremuka huko chini kwa requirement. Part A inasema determine the cost estimation equation using the account analysis method. So hiyo ingine tutasoma when I give you these other methods. Now, as I've said, what happens with this method, you look at those costs. You have the cost item. The cost item ya kwanza ni variable. So we have the variable and we have the fixed. So we prepare a table of that design. A table of that design. Now, when you prepare that table, you start classifying. So the first item is indirect materials. Indirect materials. Indirect materials, we are told it is variable. And our costs are in thousands. So 37,500. 37,500. So hiyo unaiweka kwa category ya variable. The next one is indirect labor. Indirect labor. Indirect labor We are told 171 is fixed and the total is 194. So give me the difference between the two. Because 171, hiyo tutaiweka hapa. The difference between 171 na hiyo 192, no 194 ni ngapi? Is it exactly 23? 23,200. Yeah. 23,200. Ama your figure haina 200? Patricia?
Iko nayo, sikuwa nimeona.
Okay. Then the other one is rent. Now rent, we are told it is fixed 236,420. 236,420. Then electricity, we are told it is variable 27 to 10. Then equipment depreciation, we are told it is fixed 181,000. The next is equipment maintenance. Equipment maintenance. 8,500 is fixed. So hiyo niweke hapa. Give me the difference. Give me the difference. $15,830. 15,830. The next is personal properties or personal taxes. Personal taxes. So for the personal taxes, 6350 is fixed. So give me the difference. Hakuna mahali sijui kama imeruka. Okay. 4870. That's personal taxes. The next is data processing. Data processing. So data processing is 9470 fixed. So the difference with 11,220. Give me the answer. 1750. And finally, we have technical support. technical support, we are told it is fixed 16,940. 16,940. So that is all. So with that, we get the totals.
I think there's somewhere we did wrong because of how it skipped.
Where?
The one for equipment.
Equipment depreciation is 181. Yeah, najua kuna mahali kwa your past papers kuna mahali iliruka. Equipment ndio 181.
Equipment maintenance
Ni 24,330.
and then personal tax
Ni
is
14,100. So that the data processing ndio 11 to 20.
So here, yeah, personal tax 14,100 minus 6350 in a letter 7,750.
7,750 hivyo. Then data processing, is it okay? Hiyo 11 to 20 minus 9470.
1,750, it's okay.
Okay. Good. Nilikuwa najua kuna mahali hiyo past paper iliruka. Haya, so now give me the total ya variable na total ya fixed. Haya, variable 113 240 as the total. Fixed 629 680. So that is from Caro. Patricia, are you able to confirm those figures? Good. So with that now, our A, the fixed costs, is this 629, 680. Our B, the variable costs. B is the variable cost per unit. Now, what we have gotten here is the total variable cost, 113,240. So we must divide by the number of units that we were told about. We were told about 800,000. But because our figures here are in thousands, we shall talk of 800. we shall talk of 800. So 141.55. So that gives us our function as y is equals to 629,680 plus 141.55x. So that is the cost function. That is the cost function. That is the cost function. So that is what they wanted. Sidhani wamewahi test hiyo method any other time. Maybe your exam ndio itakuwa the next. So let us go to the next method. The next method is called high-low. The next method is called high-low. And here it is. So in the high-low, what you do, you just identify the highest and the lowest values of x. And then you take the corresponding values of y. Now we are talking of corresponding. That means the value of x, rather the cost for x. So when we go to y we do not go selecting. Y we do not go selecting. Only in x we select. Then you develop an equation. You develop an equation of y is equals to a plus bx. So let's do that. We are still going to use the same question. We are still going to use the same question because it has that requirement. It has that requirement. So the next method is high-low method. And we are using the question of December 2004. Question 1, now B. Question 1 and part B. So I would like you to go to the information that is provided in number 3. Information that is provided in number 3. Additional information number 3. And before we do that, first of all, we need to write the format. The format is y is equals to a plus bx. That's the format of the equation. That's the format of the equation. So, nataka uende kwa information number 3. And our units will be our x. You scan through those values of x, you tell me the highest. You tell me the highest of those values. Those production units, the highest you can see there.
$98,000.
98,000. So that 98,000, the cost for it if you look at the cost for it, it is 777,640. So hiyo ndio unachukua hapa, unaweka 640 should be equal to A plus X. X is 98. So this is the highest. That's the highest. Higher. Now, pick the lowest number of units there. The lowest number of units.
$56,900.
56,900. The cost for that is 717,670. 717,670. It is 56,900. And this is the lowest. And there is something I would like you to observe. If you look at the values of costs, is this the highest? E777, is it the highest? Is it the highest?
Yes.
Good. So it can be the highest, but hatujaichukua sababu ndio the highest. Tumeichukua sababu it is the cost of the highest units. So kama kungekuwa na ingine that is higher, a higher cost, hatungeichukua, tunachukua tu hii because it is the cost of this. Haya, hebu angalia hii uniambie kama ndio the lowest.
No, it's not the lowest.
Yes. So it's not the lowest, but it is the cost of this. So that's why we have picked it. So I would want you to note that when we go selecting, it is only in the column of X we select. Ukisha identify the highest units, unachukua cost yake, whether you're the highest or not. Ukisha identify the cost of ukisha identify the lowest units, unachukua cost yake, whether you're the highest or whether it's the lowest or not. Whether it is the lowest or not. I hope that is understood. Higher. Now we solve these are simultaneous equations. So you just draw a line there, then you say subtract. So niambie, this 777 minus this 17.
$59,970.
59,970. Higher. Give me 98 minus your 56.
$41,100.
41,100 B. So from there, it then follows that our B should be 59,970 divided by 41,100. Oh, already the answer has come. 141.55. Ama hiyo ilikuwa ya kitambo?
Ni ya kitambo.
Okay, haya, give me the current.
1.459.
1.459. So if that is the value, then sasa una proceed unasema 777,640 is equals to A plus 98,000 times 1.459. So the value of A should be 777,640 minus 98,000 times 1.459.
Six 645.8.
0.8.
Yes.
So that means now our equation is y is equals to 635.8 plus 1.459x. That's how we use the high row method. And the high row method is very, very, very important. Very, very important. That is the second thing I'm telling you, very, very important after the equation. Utakuwa unaiona ikitembea kwa many topics. Utakuwa unaiona ikitembea kwa many topics. So the earlier you make peace with it, the better. The earlier you make peace with it, the better. So I don't know whether your papers have December 2007. Wachana na hiyo. Take this as an assignment, the one that you shall do. Ama nitumie hii. Hii nitaitumia kama nimepata zingine. Hii nitaitumia kama illustration. So let me look for another one. Haya. This one of May 2021. May 2021. Question question 2A. Question 2A. Hiyo ninasema itatumia kama illustration, sijui kama itakuwa ya. We can use a different one. So let me give you this other one. Because naona iko na huge values na hiyo illustration nataka itakuwa na squares. Sitaki ku square huge values. So December 2024, question 1B. December 2024, question 1B is the same concept, So that is about the high row method. Very direct, very simple like that. Very direct, very simple like that. Before we sign off, I still have 10 minutes, which I can use to bring the next method. So the next method is called simple regression analysis method. And this regression is a statistical method that we use to study two things. One is the nature of the relationship, and number two, the strength of the relationship. You know, in our lives, we form relationships. Actually, I say life is relational. You cannot exist without relationships. Now, we form relationships with very many people for different reasons. So, as such, then we need to know what kind of a relationship do you have. Like now, me and you right now, we have a relationship called teacher-student. That's the nature. And we may also want to know the strength. The way I relate with the three of you, some of you are closer to me than others. Wengine ndio tunaonana, wengine tumejuana. So it could be the strength is more in one area compared with the other. The three of you, you have a relationship called classmates. That's the nature, classmates. Now, that relationship could also be stronger between any two of you compared with the other one. Yeah. So we want to know the type and the strength. And it's called simple because it has only one independent variable. When you have one independent variable, that relationship is called simple. But if you have more than one, it is called multiple. It's called multiple. Now, the general format is, as you can see here, the formulas well articulated. We shall be using them. The other thing that you need to know is that when we talk of the nature of the relationship, we look at the sign of the slope, this one, the sign. And something else we call the Pearson product moment correlation coefficient, R. And we have three types. So this is a formula of R. We have three types of relationships. There is what we call direct. Now, direct, it is where items are changing towards the same directions. And we also call it positive. Inverse, it is where we are changing towards opposite directions. And is also called negative because the answer is negative. Then we have what we call null. Null is where a change in one has no effect on the other one. A change in one has no effect on the other one. So that is what we call the simple equation. So I think we will, the 2 minutes can still be used to answer. Hiyo swali ya December 2023. No. Hiyo, we can answer in 2-3 minutes. We can answer that in 2-3 minutes. Although, so we are now in method number 3, simple regression. Method. December 2004, question 1C. Now, if you're looking at that question, the answer to that, you see in part C, they are saying using the simple linear regression, estimate the cost. So here we are not going to use the formula because if you look at information 4, let's read information 4. Information 4 inasema, when the information above was entered into the regression program using only the production level, only, that means 1. Using only the production level as the independent variable, the following results were obtained. So we are given that equation. So you just copy. So the equation is y. Remember y ndio inasimamia the total cost. So it is 626,547 plus 1.54x. That way. Maybe what you could do ni kuambia y inasimamia overheads and x inasimamia production units. Kama hujaikopi venye wameandika hivyo. And now we are told to predict. So the forecast costs for 800,000 units. We normally write it this way. Y predicted. Ukiona Y predicted, hiyo inamaanisha forecast. So unachukua hii equation 626,547 plus 1.504 times 800. Remember the equation is in thousands. This one is in thousands. So if it is in thousands, when you are substituting, you must comply with that. That's all that the candidate was required to do there. Just interpreting that computer printout. Solving regression using computers. One of the things we are doing in BDA. So we will stop there for today. But when we meet, God willing, we shall now do another one so that we show how do you derive this using the formulas. That would be good. So if you have any query, you can raise. If you don't have, just end. Yes, Carol. Thank you. Okay, so let's meet in our next lesson on Saturday at 6 p.m. Okay. Yes, Benedette, noted. Maybe tomorrow. Yeah, tomorrow is when you can get it.